Thank you. Welcome, everybody. Today's event is an AI for Global HIV Research Opportunities, Application, and Resources. This is an event co-sponsored by the Yale Global HIV/AIDS Research Network, Garner, and the Center for Interdisciplinary Research on AIDS at Yale University. Very quickly, in terms of today's event and coordination, so we will start with introduction to the panelists and some brief presentations by the panelists, followed by discussions. And then we'll have a Q&A with attendees, and we invite you to submit your questions using the Q&A feature. And then at the end, just when you leave the Zoom webinar, we would love to have your feedback on today's webinar organization, as well as suggestion for topics and speaker for future events and activities. And I forgot to introduce myself. My name is DeMayo. I work at CIRA. And with that, I will pass it over to Dr. Luke Davis, who will be moderating today's webinar. Thank you.
Good morning, Denny. Thank you, and good evening to those who are joining us in other time zones. We're extremely happy to have you with us today for this panel entitled AI for Global HIV Research, Opportunities, Applications, and Resources. As Denny mentioned, my name is Luke Davis. I'm a physician epidemiologist. I'm based in the Yale School of Public Health, where I'm an associate professor. I'm also a faculty member in the School of Medicine, and I'm pleased to be putting this event together with my colleagues, Dr. Sheela Shenoi, who's an associate professor in the Division of Infectious Diseases in the School of Medicine, and also with much support from Denny Harsono and Jeff Wickersham, who's also one of our panelists. I'd like to give a brief introduction to each of our three distinguished panelists, and then we'll jump right into it because we have a lot of interesting things to talk about. And we especially want to engage you as attendees to answer your questions. Our first speaker will be Professor Bhramar Mukherjee, who is Senior Associate Dean of Public Health Data Science and Data Equity here at the Yale School of Public Health. She's also the Anna M.R. Lauder Professor of Biostatistics and of Chronic Diseases Epidemiology. And she serves as the Senior Associate Dean and founder of the Data Science and Data Equity Center here at the School of Public Health. She also holds a secondary appointment in the Department of Statistics and Data Sciences and is affiliated with the Macmillan Center and the Institute for Foundations of Data Science. She also serves on the Yale Cancer Center Director's Cabinet. We're also joined by Justin DeMayo, who is a system and application specialist at the Yale School of Medicine, where he's responsible for the framework, security, and maintenance of the medical library systems, as well as application development to meet the needs of the medical library staff and mission. His focus includes cloud infrastructure, automation, and innovative application development to support the medical school's mission. And he's taken a great interest in artificial intelligence and will be sharing with us those resources that are available at the library and throughout the university. Finally, and definitely not least, is my friend and colleague, Jeff Wickersham, PhD, who's Associate Professor of Medicine and Infectious Diseases at the School of Medicine. And Jeff also directs the mHealth Research and Innovations Lab at the School of Medicine. His research focuses on improving HIV treatment and prevention outcomes among sexual and gender minorities, including transgender women, gay men, and bisexual men. And his research is focused on developing biomedical and behavioral interventions, including peer and patient navigation, implementation of PrEP for HIV prevention, develop of AI-based chatbot technology to improve the uptake of HIV testing, and also adapting mHealth applications for transgender women to scale up HIV testing and linkage to PrEP services. So without further ado, I'm going to turn it over to Dr. Bhramar Mukherjee. Thank you.
Hi. Thank you, Luke, and thank you, everyone, and thank you, CIRA, for putting this event together. I am going to share my entire desktop because I have some demos with Gemini. So my task was to talk about AI for research. And I said my 2 cents because there are 2 aspects of AI for research. One is doing research on AI, which is a large part of our portfolio, but also how to augment your public health research workflow with Gen AI tools. And I want to say that the month of May has been a cornerstone and watershed moment in AI with these 3 Nature papers coming out, which could be game-changing and transformative for any kind of research. I do want to spend some time talking about that. But before that, I would let you, for the first 2 minutes of this presentation, I'll let you think about and reflect on how American people are thinking about AI from a survey conducted in 2025. Because I always feel that as researchers, we are very excited and talking about AI in a different norm, but public, and a root of the word public health is in public, how they are perceiving AI. So as you can see that in this slide, I've taken this from the Pew survey, and there are many other surveys as well, which are talking about this issue. And this is a scale of how awareness around AI has increased over time. Since 2022, ChatGPT was released, and you can see that it has continuously increased. But there is still 53% Americans who know nothing at all or a little. So as we are thinking about progress, I think equity is a fundamental principle. We think about those who are invisible to AI, and AI is invisible to them. So in terms of adoption, we can see that adoption is increasing, and not at the same rate as awareness. What really many of us are thinking about, that 1 in 10 teens say that they do almost all of their schoolwork with chatbots' help. And this proportion is also increasing. This cognitive offloading is something which is definitely going to impact future research. So in terms of enthusiasm and excitement and fear about AI, and you can see that where American public think that about half say that it is going to worsen creative thinking, critical thinking, and meaningful relationship, the human connection that we truly, truly treasure. Also, more concerned about AI than the increased use in daily life. However, Americans do think that AI will affect medical care positively. And in this figure, you can see that what are the percentage of positive. The blue is the positive, and medical care is one of the, and health in general is one of the more positive sectors. Where do you think in various degrees of support AI should be used? And this surprised me because this forecasting the weather or credit profiling, fraud detection, these are traditional use of narrow AI, and maybe some of those historical thinking is also influencing this survey. But in general, people who are doing AI, experts in AI, people on the panel who are on board are more enthusiastic. And you can see that the positive among US adults and AI experts is very, very different. So whatever we say has to be taken in the context of what the general public is actually thinking about. So another major concern, and as I said, that I always think about this, that my own work has never been influenced by 5 corporations or the big AI companies in so profound ways, because we are developing a dependency on our coding, on Claude, on GPT. But whose views are represented well and who is invisible to AI? So this question really was very poignant. And as you can see that the percentage of US adults who say that whose viewpoints are respected and represented well is 42% men, and also 40% of white, we believe that white adults are being represented. And this is probably no surprise, because if you look at the leaders of who is thinking about these companies, and it is really, we have to think about, I just finished teaching a course on ethics and equity in data science and AI. So it's time for some thinking about the power hierarchy in terms of knowledge. So with that, I'm going to give you a glimpse of how my research has been influenced and how public health research is being influenced. And I'm going to focus on public health in particular, because it's very broad. And in the end, I'm going to talk about the general framework. So these are a couple of papers which I found to be useful, and you can definitely have access to my slides, where in health, AI applications are more profound. In public health, in social care, in medicine, and in operationalizing health systems. And in every sector, the use cases are very, very different. In some cases, disease surveillance, in some cases, finding out the right drug. And this is a very useful framework to understand that this broad AI, which is not narrow AI, has applications everywhere, and the applications are quite different. But what are some core pillars governing these applications, where may it be governing a health system or prompting someone to get screening done? It should be based on high quality, inclusive data. It should be that our systems are interoperable, and also they are addressing the problem and the population to which the inference is being built on. One of the major limitations of these generative AI models could be that the training data is so biased. Who is invisible? Which populations are invisible? The visually disabled population, the incarcerated population, people who are working on 5 jobs. Yale is very different than New Haven. So we really need to think about population. And that's where some of my own work has focused on the epidemiology of AI and the data equity of AI. So when I started last year, I can show you that I started using deep research from for my own research. And so this is a guide that came out, and prompting is extremely important when you are using the LLM tools for your own research, because a configuration of prompts can change the in-context learning. And so this is deep research, and this and Justin is going to talk about it. Deep research is integrated in a part of every ecosystem. And when I started, I'm just going to give you an example of this prompt history link. So this was about South Asian biobanks, and you can see that I started with, I wanted to say that there is data paucity in terms of genetic data in South Asia, and I started chatting with the deep research, which many of us do. And these have incredible capabilities of thinking about pulling together what are the major biobanks in the world, what are the major biobanks in South Asia, what is the genomic diversity. So this is how I started talking about it. But then, can you see my slides again?
Yes.
Yes. So that interactive workflow led to this paper, which just got published in Lancet Regional Health. And what did I do? So this putting together those tables and data would have been 2 months of work for my graduate student. But now that we could finish that in 1 week, what we did was to actually convene the PIs and the leaders of these biobanks and have a consensus panel thinking about what would be the right modality if a South Asian biobank is going to happen. So this, I thought that putting together those tables and giving that information did not really lose any part of my sort of understanding of the topic. This is where I did not delegate my understanding, but delegated some of the tasks and spent more time in talking to the stakeholders. I'm actually really, really proud that we have investigators from Sri Lanka, from Pakistan, from Bangladesh, from Nepal participating in this consensus, and we all co-authored this paper. So I think that if I spent most of my time in getting the quantitative piece together, I'd be able to do that end-to-end research. So from using chatbots passively, now we are very, very rapidly moving towards agentic modeling. And this has been really, really transformative for research because the agents can actually take decisions. When you are looking at a chatbot, you're doing prompting and it is predetermined. The course of action is predetermined by you. And here, agents, and particularly multiple agents collaborating with each other, can audit each other's work, can influence each other's work. And this is how people feel much of the lab work or teams are going to be run in the future. So in health, we are seeing an incredible use of multi-agent models, particularly because of the different drug databases, the phenotype databases, the clinical trials that we have, the ability to memorize and ingest vast amounts of data and translate it into prioritized hypothesis. So I want to share with you that how this can be useful for any research. For example, this tool, paper to agent, can translate any paper that you are excited about so that people can interact and learn and use from it, paper to agent. There is another tool called paper to code, which I'm trying to use for many of my papers that I'm curious about and I'm building on, is actually taking the code from GitHub and translating the code of the paper. And I want to say that this paper last year in Nature, in September, Professor James Zoe, when he came and talked to us about this paper, all 400 of us who were attending his workshop virtually or on site at Yale were completely blown away, where LLMs, where this is a paper in Nature, where virtual labs were run with human interface and anti-nanoparticles, which are going to bind with SARS-CoV-2 nanobodies, were identified. But the team, a quantitative data science team, did not stop there. They actually took, just like I took them to the consent, that took the findings and built a consensus, they took it for a wet lab experiment and produced data to show 5 of these compounds that they had identified actually binds with the antibodies. So this is where research may look like, the end-to-end research, where the question and answer is going to be very important. And what you do with the answer, you'll probably take the answer to the next stage. As I mentioned, to conclude, because I only have 10 minutes and you can probably see that I could do 10 hours or 10 days on this topic. So there is this moment in May 19th. 3 papers simultaneously came out in Nature, which are actually when AI is able to generate new ideas and new hypotheses. Future House, a company, produced Robin, and Google DeepMind and Google released Co-Scientist and ERA, which is an empirical research assistant. And I have put the GitHub link to this empirical research assistant. And so it is actually a game-changing moment where they generated new hypotheses for different case studies and played a tournament in a game theoretic perspective of promising hypotheses. And then those leads were tested in cells and animals and finding promising drugs for age-related macular degeneration, liver fibrosis. This is really phenomenal. And if we go beyond health, for example, in mathematics, those of us, I'm a math major, so I always follow math breakthroughs. And only last week, OpenAI model actually disproved 80-year-old standing conjecture by Paul Erdos on the unit distance problem. I strongly encourage you to actually listen to the video and watch the video, how mathematicians from Cambridge and Harvard and Stanford are supremely excited and cannot sleep how this happened. So there is tremendous excitement beyond health as well. But with these massive models comes the challenges. These models are scaling at some unprecedented greed in terms of model size, data size, and compute. And if you think about the number of parameters, we deal with like a 20 parameter models in statistics and we prove theorems about it. These models have billions and billions of parameter. And with that comes large labeling data. And many of these datas and videos and audios are being labeled by populations in impoverished communities. And again, this is a beautiful documentary, Humans in the Loop, when women in villages of India are labeling videos from morning to evening. What are the humanitarian cost of it? And we are going to talk about this, but I wanted to show you a slide that with every click, with every query, with every progress comes this energy consumption, what we are doing to nature, the water consumption, the quality of water around data centers are decreasing. And I did not know about this, but there is an increasing rate of mining earth minerals and rapid, because these models are being recycled at such a fast pace, the hardware and e-waste. So to end, I'm just going to say that like every transformative moment, a radical transformation is happening to society and science. We have to go through it. And art is very comforting to me. So I'd end with a quote from Rilke: "Let everything happen to you, the beauty and the terror. Keep going, because no feeling is final. This is going to change." Thank you very much, and I'll hand it over to Justin.
Thank you, Bhramar.
Good morning, everyone, and thank you to Garner and Sarah for bringing us together. When people think of the university library, they often think of quiet stacks of books and archival paper. But today, the Yale Library functions as a dynamic data and technology sandbox. My role at the medical library is highly hands-on. I teach introductory AI literacy, Python programming, and research data computing classes. I work with students, faculty, and global health researchers who are trying to figure out how to transition from the hype of artificial intelligence to actual day-to-day utility. Our goal at the library is to build AI literacy. We want to demystify the black box of machine learning and give you practical technical fluencies required to accelerate your research without compromising your academic integrity or data security. Right now, Yale has curated an incredibly robust ecosystem of AI resources. So for general text generation, brainstorming, and coding assistance, we have the Yale Clarity platform. Clarity gives us secure in-house access to the frontier models from the leading companies all in one platform. And it's unlimited access to where even with subscriptions, you get cut off depending on how much you pay. So it gives kind of a sandbox to explore what each company's models do and compare them and to use them for work. And then recently, Clarity rolled out a support for self-service custom agents where you can kind of build your own agent that can retrieve data based on data that you provide it. And so that gives people more access to what AI can do to help you, more than just being something to chat with. And they've also rolled out end user API access for development exploration and coding agent use, which really is where you'll get the most help with your research in terms of AI uses with agents, or if you do any sort of coding or trying to understand code or data analysis, having a coding agent or an IDE, integrated development environment with AI built into it, where AI can look directly at your files, is a much more efficient way to use AI than copying and pasting back and forth from a web interface. For literature discovery and synthesis, Yale users have enterprise access to Google's Notebook LM, which is great for interacting with and summarizing your own uploaded PDFs. So you can upload a bunch of your own data or notes and explore those in their platform. While anyone can use a free tier of Notebook LM, one of the institutional benefits of using your enterprise account through Yale is data security. And so that would be a common theme of a lot of things I touch on, is that you can access a lot of the free tools, but you're leaving it up to these companies and trusting them with your data. And so if you're working at an institution that provides you access through enterprise agreements, you have a better level of data security and agreements to where your data isn't going to just go anywhere based on the agreements that your institution has made. Furthermore, the library recently launched a year-long trial of Consensus, which is an AI-powered search engine that extracts evidence-based findings directly from peer-reviewed research. So if you're at the university, it's a good time to trial that software to see how it works for you. We're also looking toward the future of catalog research. So Yale Library is piloting a project that uses Model Context Protocol, or MCP, to integrate conversational AI directly with the massive library catalog. So it will allow researchers to use semantic and natural language queries to discover highly niche or foreign language text that standard keyword searches often miss. So the library is looking at using AI to power their search and discovery of the collection. The medical library specifically also has Ask Harvey, which is our AI assistant on our homepage, which helps you explore everything about the medical library homepage. You can explore the collection, you can do basic searches of PubMed, and that's an agentic AI system that was developed at the medical library. And our medical library has also worked with the YSM medical education curriculum to create a chatbot for students to explore the curriculum through a chatbot interface. And so it's been has access to the curriculum data for students to explore. So tools are only half the battle when it comes to using AI. The most important aspect is support infrastructure. So whether you're a principal investigator or a student encountering Python for the first time, we have the Yale Library Computational Methods and Data team. They offer direct consultations and classes. The medical library also offers classes on using AI as pair programmers or just AI literacy in general. And then there's also direct consultations with our data bioinformatics, research and education, and clinical librarians. Crucially, as we discuss global health and HIV research, we have to look beyond our campus borders. International collaborators frequently face a digital divide regarding expensive enterprise licenses. So we're talking about our enterprise licenses. It's great if you're here and you have those. But then if you don't, there's other options where you can avoid the, what's happening with my data if I'm just using a public platform. And so you can leverage open source local models. So Meta has Llama, which is a large one. And so other local models as well ensure that global research capacity can be equitably distributed. And there are platforms like huggingface.co, where there's a lot of local models that people have trained or built up that you can download and use locally on your computer. This is hardware depending, but there are sizes that will work on a variety of hardware. And so that's something you can do to leverage large language models and AI, but while not incurring the API costs or usage where you're not utilizing a data center for every interaction with AI. So if you're able to focus on edge computing of using your device with large language models, you can alleviate a lot of the concerns, not a lot, but some of the concerns that come along with environmental usage or ethical usage of large language models. We also discuss specialized medical platforms like Open Evidence. While it's hard for us to really dive deep on Open Evidence because you're only allowed so much free level access, it's important to look at these platforms to evaluate them. But there's always data privacy trade-offs. So anytime you're given access to a platform, so if you have a national provider number, an NPI number here, you're able to use Open Evidence. But I would encourage reading their data use agreements and their privacy statements to see what's happening when you use that because they're giving you that service for free. So it's important to know what's happening with your data when you use a platform that is free for you. So we emphasize data safety at the library. Yale utilizes strict data classification guidelines. So if you're using high-risk data or proprietary research, you cannot simply just drop it into a public or free chatbot. So here you need to use secure, Yale-vetted, and appropriate data risk supporting platforms like Clarity. So there's different data classifications that you can use different AI platforms here. And so it's important to know what type of data you're working with and then where you're putting it. Ultimately, AI is just another tool on the research toolkit. It cannot replace human insight. And the library is committing to ensuring that all of our patrons have the literacy and resources to use these tools safely, ethically, and effectively. I look forward to diving deeper into the questions today. Thank you.
Thank you very much, Justin. That was a wonderful overview. Just to remind everyone, we're starting to accept some Q&A in the chat. Please put your questions there. And now we'll turn it over to Jeff Wickersham, our third panelist, to talk about his work with AI.
Thank you, Luke. And thank you to the organizers to the panel. Thank you to YIGH and to the Garner Network for today's event. Today, I'll be speaking about a study that our team did several years ago, ended about 4 years ago, on using an artificial intelligence chatbot to improve HIV testing and HIV prevention uptake among gay and bisexual men who have sex with men. But like most things in my life, I like to reference or punctuate milestones with pop culture events. So when we started talking about AI and research, this was probably eight years ago or so, My only really known reference point for AI was the TV show Knight Rider, which was back in the 80s with David Hasselhoff, who drove a car called KITT, which was a artificial intelligence Pontiac Trans Am that was fundamentally generative AI car, and it helped him fight crime. And of course, I loved it as a kid. A lot of Gen X and millennial folks did, but that was 40 years ago, and that was fiction. And here we are in 2026, and AI has made massive leaps just in the last few years alone. So the project I'm going to share today started in 2020. This is before generative AI and the release of ChatGPT publicly in 2022. So I just wanted to couch where this project emerges in the timeline of AI. The project was funded by NIAID through an R21 two-year exploratory pilot grant. And the goal of the study was for us to build an AI-based chatbot for users in Malaysia who were gay, bisexual, and other MSM at risk for HIV to interact with, receive information, learn about HIV prevention, and to order HIV self-testing kits and get referred and linked to HIV prevention services in the community. We were literally starting from a foundation of nothing. So this was really exploratory in nature, and we conducted a great deal of alpha and beta testing of our chatbot that was created with our team through a third-party vendor. And we wanted to evaluate users' engagement with the chatbot, look at its performance, how well did it perform. And we also had intended to have some training of the chatbot. But in order to really do training for the chatbot to learn, it requires quite a large volume of that training data, which, in a 2-year small pilot, we really didn't have the capacity to provide. After we developed the chatbot, which I'm going to share with you on the next slide, we needed to find a place to deploy it. And although there were a lot of suggestions from putting it into an app to putting it available on some apps like Telegram, we wanted to make it much more publicly available than that. And so we went with placing it on a website. So we had to actually go and build a website. So we built a web platform that was centered around HIV treatment and prevention, education, and resources for all of Malaysia. And the website is still live. It's myhiv365.com if you want to go to it. And this is where we deployed the chatbot so that users could come to it and use it. And for most users who engaged with it, at the time, of course, we had the problem of consent. How do you consent somebody into using it? So we really had to distinguish the website itself, which was publicly available, from the chatbot itself, which was a research tool. And that also presented a lot of challenges. But after we built the website and deployed the chatbot, we did a great deal of internal testing, a lot of back and forth with our vendor who was building the chatbot. We had to import all of the HIV treatment clinics nationwide in Malaysia into the chatbot. We had to manually import all of the nation's private and public PrEP providers into the chatbot. So it was a very large undertaking at the time. It was, again, 6 years ago. And this is the chatbot that we came up with, and I'll just show a brief demonstration. It was a very much, as Bhramar pointed out earlier, this was a very passive chatbot. It was mostly a closed system where users tapped a choice, but they were allowed to enter their own free text. Oftentimes, the text that they entered would be unrecognizable to the chatbot because it was so young and new and had not learned. But we kept the scope quite narrow: HIV and HIV testing and HIV prevention. So you can see as the chatbot engages with the user, they've decided to get an HIV test at a clinic, and they can then enter their location, and we find the nearest clinic in their particular town. We also offer to email them the list of the clinic. The chatbot then automatically creates the email and sends it to the user so that they can have access to it. There's no login feature for this. So that was something else we heard from users is they don't want to have to log into the chatbot. They don't want to have to identify themselves. In Malaysia, which there are criminal penalties for same-sex activity, same-sex sexual activity. So people were very reticent to share that information. But you can see the email pops in right there at the top of the demonstration. What were some of the results from the chatbot? So in our interviews with people who used it, we found that they wanted the chatbot to be more conversational. They were frustrated that the chatbot would come back and say, I don't know what you mean. If you entered anything that wasn't specific to HIV testing and PrEP, your answer was somewhat, ended on deaf ears. They wanted it to be a much more interactive, which at the time it simply wasn't. It was a very narrow tool. But people did report great satisfaction with the use of the tool for ordering and delivering and shipping of HIV self-test kits. This was something they enjoyed and preferred using the chatbot over other forms of platforms, which required them to enter a lot of personal information that they didn't want to disclose. And as far as the information that the chatbot provided about HIV, participants reported high levels of trust in the information. They felt the information was accurate and beneficial to them. But what were some of the challenges of deploying this AI chatbot? As I mentioned earlier, it was this learning phase or training phase for the chatbot. It really required a lot more data than we had the capacity to provide it. So there wasn't a great deal of training that could happen. It was a much more, again, closed, passive chatbot. There were a lot of technical issues that we ran into. The chatbot would, for unknown reasons, would stop the chat with the user. It would freeze. The chatbot would suddenly change languages without being prompted to. Users really found that deeply frustrating. And given the advances that have happened with these large language models, as Bhramar was speaking about, it seems to have made chatbots like the one we created a little bit less attractive. However, it does seem to have a potential niche use, because a lot of folks who were in the study reported that, because it was a closed system, they felt that their privacy was somewhat more protected. It wasn't easy to identify who they were as a user, and they also felt that in a closed system there was less likelihood that they were going to encounter inaccurate information. So I think many people in the audience and on this panel can attest to AI, going a little rogue and providing information that is inaccurate. And this closed chatbot was less likely to do that, although it was more likely to randomly change languages for users. I just want to provide some acknowledgements on the left and happy to take any questions at the end.
Thank you so much to all of our speakers today. We're going to open it up now for some discussion. There were several questions in the chat, some of which have already been answered in the chat. But I wanted to take a question now from one of our attendees, Anita Cole Pomnani, who's asking, can research abstraction be done using AI, leaving senior researchers for higher level work? Will this keep junior staff untrained for higher level later in the future? And certainly I think this comes up a lot. I think this is touching on skill building and creativity, that maybe people maybe not developing those skills during their training as they originally intended to be, due to the advent of AI being able to do some of those tasks at this point in time. And I'm hoping our panel can comment on this.
I'm happy to share my thoughts on this because, yes, I do think that there is a lot of risk if AI can do so much of getting detached with the material and in pedagogical terms, cognitive offloading has become a phenomenon. And then if you do the cognitive offloading and you did not extract that material, then you have a metacognitive disengagement with the material because you are not really processing it as if you actually did it or wrote things down. And what are some of the ways? And I think that at the AI for Yale, AI at Yale conference, some of the best suggestions I thought came from students who are at the receiving end of this, that how do I use it? And there was a suggestion of, which I really, really loved, about if you use AI at this particular stage of research, what are you gaining and what are you losing? Clear statement of that. In the future, which skill would you not have if you actually delegate this particular task to AI? And some of the tasks, for example, when I'm planning a study, doing a power calculation is something I can easily delegate to AI because I don't feel that I learn. But in terms of the study design, I really, really have to interact with the investigator. So blocks and pieces where it can be used without sacrificing that deep understanding. And then in our educational process, more and more, I think how you can explain your ideas, stand up and explain your ideas, is going to be very important. I just finished teaching a course where all of the assessments were through presentation, and the final exam was actually a closed door one-on-one conversation with me. So even if you write your report and you use AI, we cannot really prevent it. It has a lot of capabilities, but have you assimilated? Ultimately, take the ownership of your knowledge and think about future steps.
Yeah, Bhramar, thanks. I mean, I think you're kind of highlighting that there's ethical dimensions on all ends, and I think this came up a lot as we were planning this panel. I think there tends to be so much enthusiasm about AI, but we also you kind of highlighted in your talk, particularly towards health, the general public's positive attitude, but we know there's a variety of issues. Justin kind of highlighted a lot of the data issues, but also this kind of de-skilling issue. Maybe a kind of a question for Justin would be, you highlighted a lot of resources, and I just want to let everybody know that we're going to be sharing lists of these resources in a recording as well as the presenter slides afterwards, so that you can drill back and look back to take advantage of that. But what would you say is the best place to get started, Justin? For particularly we're thinking a lot in this panel about using AI for research. What's the best place to kind of get started at the library, just to start getting comfortable using these tools, and in terms of the first steps?
Yeah, that's a great question. So I think in terms of resources and information for the university, I will send a links to come after, because it's can be just a lot of links at that point. But the ai.yale.edu site, which I think a lot of the resources are external facing, and then there might be some that are internal that you have to authenticate. But I think there's a lot of good information there where there's guidance for every role at the university of AI. And so there's a lot of information to be gathered there. And then there's Yale Library research guides on using AI, generative AI for research, AI literacy in general. And so I think getting some information there is a great source, right? And then it's a lot of it is just you kind of get hands-on as soon as you can, right? And so really the easiest thing about chatbots and kind of trying to learn the technology is that you're just chatting with something, right? So you're interfacing with a chat interface, and it's a communication. It's what we do every day. And so a lot of these platforms now are apps. If you put any of the apps on your phone or have any computer, there's a lot of voice mode. So some work better than others. So you could do kind of voice to text, and they get a response. And then some of them have where you can just chat it with voice with the models. So there's different ways to interact with them, to just kind of see how some of the reasoning works with the models itself. And then going from that point of just chatting with them, some of the simplest ways, if you want to start using it for more kind of technical research or computing, is there's a free version of GitHub Copilot. So if you are doing kind of coding work or programming, you can use GitHub Copilot through GitHub's website directly. And that and you can tie that into kind of the VS Code, which is a development environment, and that is a good way to get kind of access to your files immediately. And so it's a good place to start. The caveat being, if it's the free version that's not through the university, you have to be cautious of your data and what's going into it. But that's a good way to just quickly get something where you can see how can a more specific coding agent versus just an LLM chatbot interact with my files and what can it do for me. And one of the big benefits there is kind of code completion. So there's a lot of people that have varying opinions of where programming and coding are going. But one of the most helpful things is as you're typing, it will just start to suggest things for you. So if you are writing, you're going to define a function, you can type def and start typing fib. It's going to write a Fibonacci function for you to figure that out. And so it's amazing to see what it can do in that space. And I think that changes the perspective of, if you work a lot in that area with coding and programming languages, you're seeing a lot of advancements really fast with AI, more so than someone that's not working in that space. And so you see more of what's happening right away, where it's kind of a lot more eye-opening, I think.
Thank you. I just wanted to move to Jeff. There was a question about, following your presentation, if you were to start a chatbot for HIV, and this was specific, your project was specifically for prevention, what would you have done differently? What would you have repeated based on your experience?
Great question. Thanks, Sheila. And thank you, Abdul. If we were to go back and do this again, I actually do think that there is a place and role for a more closed chatbot system, the closed AI type of chatbot that we developed, because it is for such a sensitive topic like HIV. And if somebody is coming to this website and to our chatbot, they're coming there for a reason. They're coming there because they either don't feel comfortable speaking about it with their own provider or with a provider at a clinic. And so I think that there is a really valuable home for this type of chatbot that is distinct from the more generative AI platforms that are available now, which most people are very, very familiar with. The second thing I would change is I would have created a human off-ramp. And I think that's something that could be a distinguishing quality of the chatbot over other generative chatbots, is if you're dissatisfied with the information you're receiving from Harris, that's what we named the chatbot. Our cab came up with the name, so it doesn't stand for anything, by the way. It's just Harris. That they can immediately be linked to a human person to chat with. Now that increased costs, of course, for either NGOs or for departments of public health to have a human on standby, and we had debated doing that, but the cost of doing it and the limitations in a research context, where if somebody was messaging at 2 a.m., are we going to have somebody available 24 hours? Probably not. So I think if we were to do it again, we would want to have a way for the individual to get connected to an actual person who could triage more carefully what their needs are around HIV.
Thanks, Jeff. It's really interesting to kind of hear you talk about what you learned, but also how the technology is evolving and what might be different in the future. One question that's coming up quite a bit, and maybe Bhramar, I think you might be able to address this, but potentially the other panelists as well, is a lot of interest in the use of digital twins as a strategy for, let's say, HIV cure research or other types of research. Maybe could you just define for the audience like what a digital twin is, and then say a little bit about this approach as a way of addressing health questions?
Yes, so I always simplify things, and I think that the ability of AI tools to find a person similar to you, right? Like who in many, many dimensions. And I just give you an example in a particular electronic health record context, that we look at people, and now we have amassed data from many, 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 many health centers, millions of records. And so the whole goal of precision medicine used to be that the right treatment for the right patient at the right time. So in order to do that, you need to understand and characterize patients at a very granular level. And so if you want to, previously will match people with respect to course criteria like age and sex and ethnicity, and sometimes maybe in terms of finer genetic ancestry. But now we have the ability to really do research in which we can sort of find somebody exactly like you and a group of population in many, many molecular and environmental and social dimension. And also think about causal inference and counterfactual situation where this person sort of really works as your digital twin. And one can also simulate and synthetic data, right, about peak populations like this and use it for forecasting and matching and many tools. So I would say that as the public opinion says, that I do think that in terms of drug discovery and also expediting clinical trials, AI will play a huge role in the future. And we are already seeing this just because most of the examples actually in Google Co-Scientist is about drug repurposing. They are finding that, well, there is a biology and then this drug worked. And this is huge because these drugs are already approved for FDA, but now they're working for another condition. So I do think that some of these modern technologies and thinking about similarity in a very granular dimension is going to be very important. But at the same time, I also want to make sure that we recognize that this is all based on data, and which data are being ingested and which data do we have available. If we look at all of the genetic data available in the world, I want to just startling fact that 20% of people live in South Asia, and we realized this writing the South Asian Biobank paper, but less than 2% genetic data come from South Asia. So when this is happening, the people who have data are going to be represented more in terms of drug discovery, in terms of genetic targeting, and all of this technology.
Thank you, Bhramar. I think that raises a really good question. That's a segue into something that's already in the chat about the confidence in results and ensuring accuracy when the model's reasoning process is a black box, specifically regarding predicting therapeutics. You were just talking about developing drug targets or new drug products. If you can comment on the confidence.
Yes, so I think like I showed several examples that AI will be able to develop target, right? That's what it is doing. From tremendous amount of data that we have, they are generating targets. And then actually in the Google Co-Scientist paper, the drug targets, there is a sort of game theoretic perspective of tournament of ranking these drug targets. But ultimately you have to take it to wet labs, right? Ultimately what they're doing is to take it to cell experiments, cell line experiments, and then animal experiments. It's the exact process of clinical trials, because you have to be assuring the patient, and those safety considerations have not been relaxed. What has been expedited is this pipeline. I do think that's what we see in virtual lab paper as well, that just testing these nanoparticles would have taken forever. And now it is 2 months. Now let us take those 92 candidates into wet lab. And even if you do that, 5 out of the 92 actually really work. That failure rate is still there, but the pipeline from question to answer, because of the massive ability to ingest data and process data, is going to be shortened. But you still need all of the steps that you need in a clinical trial to get a drug approved.
One of the things I think that comes up a lot when we think about global research, and I think just AI in general, is that it has the ability to accelerate progress, but also to accelerate disparities. And I think Justin kind of highlighted some of those issues in terms of, access to expensive models versus access to kind of free models in different places. And I wonder if maybe just in the last 5 minutes that we have, or it's probably really more like 2 or 3 minutes, any closing thoughts from the group about what ethical use of AI in kind of the global setting should look like, and how we as researchers can kind of help advance that.
Well, personally, I think that governments are going to have to step in, and regulation has to be present, has to be applied to a lot of the use of AI. I don't think there's any other way to get corporations, to get developers to apply ethical standards. I think you can see it in the big AIs, companies that are, I mean, they're in an arms race fundamentally right now. And there's, money is no object to them. But I think without regulation and without some kind of unified effort to regulate, taking an EU model, taking a UN approach to this, I think that there are those consequences, as Luke was describing, about how AI will impact people's livelihoods, people's ability to provide even clean drinking water. If data centers are consuming massive amounts of groundwater, what happens when you don't have access to that clean water anymore? What happens when entire industries and jobs are vaporized overnight by AI? So I think there needs to be, from top down regulation around this.
Thanks, Jeff.
Yeah, I think that's a good point, where it's especially the arms race for the companies, because it's definitely what it is. They're all trying to get to the end point of they talk about AGI a lot, and that they're just all racing for the next biggest and better. And so I think the things you can do locally yourself is, right, look at, how can I run local models, right? If you're concerned about energy consumption, granted, the models are still trained, they're still using probably some sort of data center resources to get to the point where then you can use it locally on your machine, but you're able to mitigate some of that usage. You're not using all the power of a data center when you're just asking it, simple questions, because a lot of the things you can ask AI are basic, and then so you could be like, well, why would I want to do that? So you can use a local model on your computer that is, smaller parameters, and it'll run, reasonably fast enough. It might not be the best frontier model, but for simple tasks, it probably will do a good job. And that's the biggest thing, is to evaluate the different models you have access to see, is this enough? So that way you're not overusing. You're not going to use the latest and greatest model for, give me, what should I wear this weekend because the weather is X, right? Because I'm sure there's a lot of that with that. So you can focus on using the appropriate size model and method of accessing it, to kind of mitigate your own usage of the resources. But there's definitely, I think, a lot of challenges that have to be met, locally, nationally, and globally for that impacts.
Yeah.
Thanks, Justin.
I work a lot in India, and I would say that the government has a huge role to play. And India just is working on its national AI plan, and there is a lot of importance on frugal AI and sovereign AI which are going to run locally on multilingual chatbots. And I'm involved in several projects where community health workers are using AI, for example, taking images of an eyelid and predict your anemia status, right? What is the hemoglobin level in the blood from images of eyelid and 5 images, and it can predict pretty well whether you are severely anemic or not in pregnant women. And so this is game changing in areas in India where you do not have the resources and also the standard reference of is invasive and taking a blood draw and so on. So I do see the possibility, and the possibilities are actually more in areas with more difficult access in terms of screening, particularly in terms of screening and prioritizing resources where there is a resource constraint. So I do think simple things like when Clarity, you run a query in Clarity, you actually know what is the environmental friendly model for a simple query. Do you actually need a complex model? So I think these types of simple interventions, policies, and AI that is for everyone, and frugal AI, sovereign AI, multilingual AI. This is going to be important for governments to pay attention and build the infrastructure for.
Wonderful. Amazingly, we are at the end of our hour. I want to thank all of our speakers, Jeff Wickersham, Bhramar Mukherjee, and Justin DeMayo for being here today and sharing their expertise and experience. Thank you so much. I also want to thank Grace Williams, who helped, our Garner Fellow, who helped organize this session, Denny Harsono, our indispensable colleague, who also organized this session, and my colleague, Luke Davis, for everyone's support. I want to reiterate that there's a survey that will come up as you close Zoom. Please complete that. It should take no more than a minute, and that helps us plan for the future. I really appreciate everyone's attendance and participation today. Thank you, everyone, so much.
Thank you.